All right, we are starting chapter 3 today. And this first section, as usual, is a lot of definitions, explanations, vocabulary. So this is all about functions, and a function is a special type of equation. Now, with any equation, there are inputs, our x values, and our outputs, our y values. Now, a function is special because it says each input, each x, has exactly one output y. And it might not seem special right now because every equation that we've dealt with so far this year has been a function. And anytime we input a value for x, we get one output for y. But now we are labeling those types of equations as functions. Now, when given a bunch of ordered pairs to tell whether a set of ordered pairs represents a function, we are looking to make sure every x has only one y value. So one input x, one output y. So what we look for is we look at our x coordinates. In this case, every x coordinate is different, and so we don't have an issue. Now, you'll see more in this x example. Notice we have two inputs of 4 here. So here we input 4, but we get an output of 0, and then we also get an output of 3. So in other words, when we input 4, we get 0 as an answer, and we get 3 as an answer. So that's no, because we had one input and two outputs when you're only allowed one output. Same thing here. Notice that when we input 0, we get 5 as an output, and we get 6 as an output. So that is a no. So we're looking for repeat x's. So the same x with two or more different y values. This one is yes. This one is yes because input, output, input, output. We can't have two outputs from the same x. This is okay. This works. So you try these, pause it, and then push play to check the answers. But I'm going to go over it now. This is a no because you can see we have 5 with 2 different outputs. This one's yes. That one's okay. You can have decimals, fractions, doesn't matter. This one is yes. We have all different inputs, so that's fine. And this one is a no because we have one input, 1/2, with 3 different outputs. Now, if you're given a graph, the way to tell if something is a function is what we call the vertical line test. A vertical line represents an x value. Remember, a vertical line, it graphically is like x equals 5 or something. So this line, right, maybe is x equals 5. And we can see if we draw a vertical line, that line, when x equals 5, only intersects the graph at one place. But here, let's say x equals 5, it intersects the graph at 2 places. So that's a no. This is yes. That's a no. So anytime you no, we don't want any vertical line to pass through more than one point, okay? If it passes through more than one point, then it's not a function. That means that there's more than one output for that input. So this one, if you can draw a vertical line and it intersect at 2 points or more, then it's a no. Here, wherever we draw a vertical line, doesn't matter, it will only intersect one time each time, so that's a yes. So here we can draw a line. This is no. This is yes. Anywhere we draw a line, it would only intersect once. This is yes. Any vertical line would only intersect once. This is also a yes. Even though it's getting narrower as it goes this way, it's still not going straight up and down. So that's yes. This is a no. We can see it intersects twice. And this is a yes. Anywhere we draw a line, it's okay. Now, independent and dependent variables. Independent, those are x values. They can be whatever they want. But our y values depend on what the x is. And so those are dependent. So we want to identify what would be the independent and dependent variables in this case. Well, in the summer, more water is used when the temperature goes up and less is used when the temperature goes down. So water and temperature are two things. Our independent variable would be temp, because that temp is going to vary. It's going up and down. It's doing whatever it wants. But the water that we use depends on the temperature. We use more water when the temperature's high. We use less when the temperature's lower. The cost of buying a salad at the salad bar is based on its weight. So here the independent variable would be weight. And then the cost depends on the weight. The cost is based on the weight, which means it depends on it. Finally, we are giving some special terminology. Domain is referring to our input values, and the range refers to our output values. And so we are going to identify all our inputs and all our outputs. So for this first one, the domain, these are all specific points. This point, we would label the ordered pair as -3, -2. This ordered pair is -1, 0. This ordered pair is 1, 2. And this ordered pair is 3, 4. So they're very specific values. So all my x values are -3, -1, 1, and 3. It doesn't matter the order you write them as long as they're all there. The range, all my y values are -2, 0, 2, and 4. So those are all my inputs and my outputs, my x's and my y's. But now when it's not specific points, notice all my x values are in between here and here. So all my x values are in between -2 and 3. And we write them as a compound inequality. X is in between -2 and 3. The inequality signs will always look that way. The range, I'll put that in a different color. The range goes from here to here. So the range is when y is, -1, and y goes all the way up to 2. Again, the inequality signs will look that way when something is in between two other things. All right, these last few examples. Here we have ordered pairs again. We have 0, 0, 1, 2, -1, 2, -2, 4, and 2, 2, 4. So my domain, all my x values are -2, -1, 0, 1, and 2. All my y values are 0, 2, and 4. For this one, all my x's are in between here and here. So notice each space is worth a half, right? 2 spaces are 1. So my domain, it goes from -1/2 to 2.5. And the range goes from -1/2, so here to here. So -1/2 and 1.5. And then for this last one, this is 1 to 5. So my domain, all the x's are in between 1 and 5. And for my range, all my y's are in between 0 and all the way up to 4.